Hello to students in the P260 class. This is a video on the stereotaxic coordinates, and what I would like to show to you is a page from chapter 3. This is page 50, as a reminder of how we use a three-dimensional coordinate system to define either the body or the brain and any location within it. So in this case of this alligator, we can see that we have an up and down dimension. This up and down dimension is called the dorsal and ventral. We also have a front to back dimension, which is called either anterior or posterior, or the rostrocaudal dimensions. And then we also have a side to side dimension, which is called medial to lateral. And we can see that this works for both a an alligator and also to humans. The only uniqueness in humans is that you have to remember that we have this right-hand turn that we have to take when we're trying to analyze this three-dimensional system in the brain. Now here is page 105 in chapter 5, where it talks about the stereotaxic atlas, stereotaxic surgery, and the stereotaxic coordinates. And so here is the stereotaxic atlas, and it shows you in a two-dimensional space one section of the brain, and it shows you the dorsal ventral features and the medial lateral features on this one page. And so from this dorsal level here, you can see that you would have to go downward or in a ventral direction 1, 2, 3, 4, 5, 6, 7 millimeters. Each of these hash marks is a millimeter, so you have to go ventral 7 millimeters. And then from this medial direction, this is your 0 point here, you have to go 1 millimeter to the left or to the right, since it's bilateral. You can go either to the left or to the right or both, 1 millimeter to find this nucleus in a two-dimensional space. Now the anterior-posterior direction is in this direction, so that you would have to find the proper anterior-posterior position, this section of the brain, in order to insert your dorsal-ventral and your medial-lateral coordinates to find this nucleus. Now, as you can see, this is a stereotaxic atlas, and the stereotaxic atlas is used to help you put the tip of an electrode into a specific nucleus of the brain. If this is the specific nucleus of the brain here and here, that you hopefully you can see that there are three-dimensional adjustments, so that you have an anterior-posterior adjustment that goes in this direction. You'll send the electrode, the tip of the electrode, in any spot in this front to back or anterior posterior direction that you need. It also has a side to side adjustment here, which is your medial lateral adjustment, and it also has an up and down or dorsal ventral adjustment. And just keep in mind here that you're always going ventrally, you're always going in a ventral direction here. This is to locate any nucleus of the brain, be it a rodent brain, a primate brain, or a human brain. Now, the example in your discussion is supposed to be a metaphor. A room is a metaphor for this whole cranial cavity. And the top of your head is a metaphor for this nucleus that we're trying to locate and define in terms of a three-dimensional space. And so you use these features of the anterior-posterior direction, the medial-lateral direction, and the dorsal-ventral direction. Where do all these directions intersect with each other? That will tell you the three-dimensional location of this nucleus in this case, or the top of your head in terms of the example in your problem. So good luck.